It seems it has always been in our nature to build, to construct. We treat a child's first set of building blocks almost like a rite of passage, understanding that building is a way to enthrall the mind, push the limits of our imagination, and discern the world around us. Traditional instructions for assembly tasks are usually step-by-step guidelines printed on paper, which require users to study them carefully and can be sometimes hard and frustrating to follow. Additionally, traditional building leaves little room for timely feedback, which can sometimes drag out the assembly process. Coupling traditional instructions with interactivity, though, can enable thorough directions and feedback that allow people to build quickly and avoid mistakes. It can enable the development of hands-on tooling to make learning more engaging and exciting. It can even assist designers with rapid prototyping by generating 3D models for the design they built in the real world. With this in mind, we present StructureSense, a tracking system based on passive UHF RFID sensing that infers constructive assembly structures from a movement profile for all of the building blocks presented in the system. We have two different use cases to evaluate the system's performance and practicality. The first of the two being our guidance application. Our guidance application provides interactive instructions for the assembly process of a shelf floor lamp. This puts our system in a scenario with a constrained sample space and a predetermined outcome. Here in the video, we can see a user in the process of building the lamp. When the user is assembling a step, our system stays in instruction mode and only shows the user the instruction corresponding to the step they are currently carrying out. In each step, the components to add are colored in yellow, as can be seen on the right. When the user finishes assembling the step, they can click a Next button on the instruction page, and the system will enter verification mode to check whether the structure their user built is correct. It is during verification that StructureSense samples and obtains the posterior belief of the possible structures at that time using Monte Carlo Markov chain sampling. This enables the system to also detect potential errors during the building process. Here, we have the same user further along in the process of building the floor lamp. The system has detected a potential error. The user must now verify if the error was on their part or on the part of the system. The user in the video has indicated that the system correctly identified this error. So now the program will return to the instruction page and wait for the user to make the proper adjustments to the system. In the floor assembly task guided by our guidance application, the participants on average took 9 to 10 minutes to complete the entire task, with the system responding to user updates on average in 0.9 seconds. This is about 2.5 minutes more than the expert time we measured. As mentioned before, building is a way to push the limits of our imagination. Each building block acts like a seed for ingenuity. Therefore, we felt it important to test how our system handles the complexity of creativity. Our authoring application enables users to create a virtual model for physical structures they build with jumbo blocks. In this application, without knowing a predetermined building outcome and facing a much larger sample space formed, our system is pushed to its limits. Here we can see a user in the process of building a duck out of jumbo blocks. Each time the user moves a component, StructureSense clusters atomic system components together into what it predicted to be within a single structure, calculates the likelihood of possible structures, before presenting its best estimation of what the current structure looks like to users. The system provides 56 potential selections of structures in total, all displayed in order of their probability of being the user's desired structure. The user can then select the correct structure from those presented, as seen in the video. On average, the participants took close to 13 minutes to complete the virtual model creation task using our authoring application, with the system responding to a user update to the construction on average in 5.3 seconds. In summary, StructureSense enables accurate construction sets and connectable assembly building instructions that allow people to build quickly, learn from their building experience, and even share their creations and design.